Hello, welcome to Berkshire Guitar Amplifier Repairs. Stuart Smith with you as always. On the bench it's yet another Fender Blues Junior. I thought you might be interested in this one though, because it's been left in a damp garage. The customer didn't know the garage was damp. It's been left in there for about, I think, 15 years or something insane. So he hasn't turned it on, and he wants me to see if I can resurrect it to see if it's playable still, or whether it's got to be chucked in the bin. So let's have a little look around it and see if we reckon we can save this little old amplifier here. Well, here we are top side. As you can see, the case is pretty filthy, but that's not a problem. Somewhat more of a problem is this rusting look, so the whole front panel's rusted. Now, there's nothing you can do about that. The actual chrome plating's lifted there, so we're not going to be able to solve that. But the customer's not overly worried about that, he just wants it working, and if we can give this a bit of a clean up, he'll take it as is. Bit of a major job to do anything otherwise there. So I think the next thing to do is to take the back off and see what 15 years in a damp garage has done to the inside of this amp, and see if it's rescuable or not. And here we are on the inside. Not as bad as I thought it would be. It's obviously a little bit corroded. It's not mouldy or mildewy or anything like that. In fact, I've seen worse on amps that haven't been stored in a damp place. So there's the valves, and oh, I can immediately see something here. Don't know if you can. So look at these power valves. Anytime you see this whiteness here on the valve, that's an absolute guarantee that the valve has lost its vacuum. In other words, the glass is broken. Unusual to see two broken like that. They might have had a bash and maybe cracked at the base, but those valves are completely useless and will need changing. These don't look too bad. You have a nice little cobweb there, look. But they don't look too bad. On the inside of the PCB, again, not too bad. I've seen a lot worse than this. So I'm fairly optimistic about resurrecting this amp. It has these IC capacitors in. That's Illinois capacitor. I don't know the true story on this, but they at one time were very highly rated caps, the best of the best. And then I think they went through a bad period or something and produced a lot of very bad caps, and now they're okay again. That's the best that I've got the story. Someone watching this may know a little bit more than I do on it. But anyway, I always check for leakage on these caps, and the way to do that is to look underneath them here. These the black side here, not that top silver side. They don't leak ever from that top silver side. It's this black side, which is the positive terminal, and you can nearly always see gunk leaking out where the lead comes out. I don't see anything on there, and if we look at this one here, this big one, a bit hard to see with that terminal in the way, but again, I can't see any leakage there, so that's all okay. I mean, we can change them if the customer wants to, but it's all money. So I don't think there's much more we can do here apart from I'll pop a used pair of valves in there, and I think we'll fire it up and see if it comes to life. You may not be able to see on this, I can see it, but there's a little hairline crack just down here on this valve, and I can just about see it there, and also on the other valve. So for some reason both of these valves have been cracked. No idea why, but that's why they've lost their vacuum, and that's why they look like that. If you ever see a valve that looks like that, it's dead. Okay, so I've got a pair of Gash used EL84s in there, and I think we'll just turn it on, see what happens. I've got a guitar plugged in. Let's see if we get any noise out of it, really. Oh, that's nice. Oh wow, lovely. Oh well, that's very good news. What's the pots like? Amazingly, they are not crackly, and the reverb works. Well, that's very good news. So this amp is basically okay. It just needs a clean-up. And I need to ask the customer, does he want this pair of used valves or does he want me to put new in? It's a little bit of a grumbly, hissy sort of noise, very faint. You might not be able to hear that. Yeah, I'll take these tubes out and give the sockets a clean as well. Yeah, they're all a little bit. Yeah, I'll just give those a clean. And then it's a question of just cleaning up the amp physically and giving it back to the customer, doing what we can cosmetically on it. Well, that's good news actually. He's got himself a working amp there for not very much money. Now, one thing I always check is the mains plug to see what's going on inside there. The fact that it's got this heat shrink sleeving here leads me to believe that someone's done this properly, but I always take the top off, make sure the leads are securely screwed inside, and that correct fuse is in there. The number of times I see a 13 amp fuse in here is ridiculous, so that is correct. 3 or 5 amp is fine in there. And obviously just get a screwdriver and make sure that these 3 are tight, which they are. And in the UK we have to have the plugs with these shrouds on here up the live and neutral pins. That's just to stop people, in the old days, used to wrap a wire around there and wrap a wire around there and plug it in and get some extra power off for something else. That's absolutely unbelievable. I can remember doing that myself years and years ago. That was days before distribution blocks, where you have a thing with 3 or 4 plugs in or sockets in. So we used to have to improvise. Just put the screw back in there. That's that little safety check done, so that's okay. And now, in terms of cleaning up the inside of here, you can't really beat a bowl full of soapy water and a J-cloth, as we call it. So that's my first sort of port of call, is to just give it a good old wipe around on the inside. As I say, I've seen much worse amps than this that haven't been stored badly. I'm not trying to make it perfect, just trying to clean it up a bit, really. There we go, that's already a lot better on the inside there. There we go, and now we can tackle the top, which will be a little bit more difficult. So I'll show you how I do that, but there are lots of different ways of doing it. Right, the first thing I do is take off the label I've put on, because it really does get in the way. It's very annoying. Now you can see it's absolutely filthy. I use this, someone else recommended it to me, Maguire's convertible top cleaner. It's for soft top cars. There are lots of things like this that do the same job. Best to get some sort of spray. I guess it's got some sort of detergent in or something. And take some tissues. I'll give it a good old scrub. It's already absolutely filthy, as you can see. I'm just waiting to hear back from the customer whether he wants new valves or used valves. And meanwhile, I can just be cleaning it up a bit. Now, there's not much we can do with this. Actually, this panel's it's actually responding a little bit to some TLC there, much to my surprise. So I'm going to use something different on there. No particular reason, just force of habit really. It's just what I use. But anyway, I tend to use Amber Cleanse. It's a foaming cleaner. I used to use this back at the BBC in the day, or something very similar anyway. And it hasn't got so much liquid in it, it's more of a foam. So we can just get stuck in here. I quite enjoy doing this actually. You might think, I should get out more maybe, but I quite enjoyed cleaning up an amp and making it look a bit nicer than it used to. There's a limit to what we can do with this, of course, because of the rust on the panel, but we can certainly improve it. There you go. That's already a lot better than it was. No point in trying to get this rust off because that's gone through the chrome finish into the steel below, so nothing can be done to improve that. Okay, that's sort of a bit of a basic clean-up. The top still looks not great, and I'll tell you what I do there to improve things. So we're going to take some ordinary shoe polish, and we're just going to give it a bit of a shoe polish basically. It's not very good quality, this shoe polish. It's breaking up a bit, which is a bit of a pain. But anyway, take an area like this area here, which is not very good, get some polish on it, and it does definitely improve it. Yeah, get some polish on there, and then a soft rag, give it a bit of a buffing up. There you go. Not perfect, but it looks a lot better, I think you'll agree. Right, that's probably as much cosmetically as we can do with the amp. I'll get it back up on the bench and we'll just do the front because that's a little bit tatty. As you can see, that top's a lot better now. And the grill cloth on this amp's quite good, which is good news. But you always get an accumulation of horrible gunk along this exposed edge here, as you can see. So we'll just quickly address that. It's obviously very easy to do that. Same procedure, just a little bit of foam cleaner, bit of tissue, and look at that. And that's all that's needed there, really. Looks, God, it's absolutely filthy, that little ledge there. Of course, it's been standing around for ages. Doesn't matter how many times I wipe it, it's still dirty. Cool, that's amazing. Right, so that really is it. Just waiting now to hear if he wants new valves or those old ones. I noticed the old ones, the bias is very high. They're pulling quite a bit of current, so we can't leave it like that. But I won't get involved in doing the bias until I hear what he wants to do in terms of the valves. So I will wait to hear from him. Okay, I've heard back from the client and he does want a new set of valves in, so I'm going to pop in a new set of JJ EL84s, and then we're going to need to check the bias, of course, because they may not be correctly biased. So let's just drop those in and I'll show you how to check the bias on this amp. Okay, I want to tell you about a fairly quick way of biasing this amp. It's not particularly easy to bias this amp, so this is a little kind of method. So here is the output transformer, which is center tapped, and the center tap goes up So this one is red, this one is blue, and this one is brown. So we're going to measure across red and brown, I'll show you that in a moment, and see what this DC resistance is here. Okay, here are the connections to the output transformer. There's the red center tap, that one, and this brown and blue here are either side of the coil. Now, I'm assuming you know what you're doing here. This is not for the lay person. All of these three connections are at very high DC voltage, 350 volts or something, so don't be touching any of those. I'm now going to just measure the resistance between, using my probes, I'm going to go from red to brown, and you will see that the resistance, look, is 94 ohms. I said it was about 195 ohms, so we're going to make a note of that. Okay, now what I've done is I've clipped on with my multimeter onto the red and to the brown, and I've set my multimeter on 20 volt range, look, because we're only going to be measuring a couple of volts, 2, 3 or 4 volts, which is going to equate to 20, 30 or 40 milliamps, as we'll see by Ohm's law. Now I just want to make you aware of something here. We're measuring 20 volts here on the 20 volt range. We're going to be measuring a 3 volts, 3.5 volts, something like that on here. Don't be fooled into thinking you've got 3.5 volts on this meter. You haven't. You've got 360 volts on this and 363.5 volts on there. So there's high DC voltages floating around here. Be super careful. Again, I'm talking to people who kind of know what they're doing here. Obviously don't take any liability for what you're doing. And I'm going to plug the amp in, let it warm up, and we will be able to read off our bias current going through that EL84. There we go, so plugged in, and switch it on, and we can watch the meter here. Obviously it'll take a while because the amp is going to need to warm up. There we go, it's warming up, look, drawing current. Bit hummied, forget about that. 2.8, 2.93, 30 milliamps, that is 32 milliamps, 33, 34. It's about 35, 36 milliamps going through there. Let me show you why that's 36 milliamps. Okay, here we go. V equals IR, so I equals V over R. We've got 3.6 volts over 95 ohms, 37 milliamps. The correct bias current for this is 23 milliamps, so this is way too high, so we're going to need to reduce the bias current. Not easy on this amp, but I will show you how to do it. Okay, I'm not going to be able to go into all the details of biasing this amp, because there are several versions of the amp, and also it depends whether you want to make the bias current bigger or smaller, and so on. So, but on this board here, which is the green board, then to reduce the bias current we make R37, which is the 33K, we make that smaller. On the cream board, there's a cream board version of that, it's a different resistor number, still 33K but a different resistor number. I've done a bias video on this amp, so do look that up if you're struggling. Anyway, so there you go, you can see I've soldered a couple of wires across R37 and brought them out up to this resistance decade box, and this allows me to dial in various resistors. So I'll put in 100K to start with and see how we get on with that, and I'm going to turn the amp on and monitor again our voltage across the output transformer. Okay, there we go, amp's warming up, and see what the current goes to. Should be less, of course, because we've got 100K across that 33K now. Looking for 25 milliamps or something. That's actually looking quite good. Yeah, I'm happy with that, 25, 26 milliamps. That was just a lucky guess, really. So if that hadn't been right, I would have just dialed in different values of resistor on the decade box until I got the current I want there. Maybe we'll come a bit down on that. I'm going to put in another 20k to make it 120k. Oh no, sorry, we want less, so I'll make it 80k. Want a lower resistor. Just dialing in on the top here. 80. That's 80k. 5, still a bit. Let's try 68k. There's 68k, and that's a bit more like it. So all I've done is dialed in 68k on the decade box, and got the resistance I needed. It's low voltage on here, by the way, so obviously always be careful, but we're not talking about any high DC voltage on this resistor here. Right, so I'm now going to take this out and solder in a 68k resistor across there and do a final check on the bias to make sure that that is correct. Okay, there's the resistor soldered in. I haven't made it super neat because I want the next tech in here to look at that and say, well, what's gone on there? And they'll go, oh, I know, yeah, he's adjusted the bias. So that will be fairly obvious, whereas if I've made it really super neat, that might get missed. So there we go. All we need to do now is turn the amp on again and make sure we've put the correct resistor in. It has been known, you know. Okay, amp going on. Turn this to 20 volts again. And watch that come up. A bit hummy. Looking for about 23, 24 milliamps. Yep, it's creeping up there, isn't it? So I'm happy with that. That's okay. So that horrible hum is just the fact we've got everything exposed and not very nice. So I'm now just going to take out the preamp valves and give the bases a quick squirt, put those back in again, and I think hopefully we're okay on this amp. Okay, there's the amp on, and it's working okay. It's a bit hummy when I take the input out. Not sure why. Okay, the reason for that hum is someone has replaced the jack socket with an open-ended one. You see when I bring my hand anywhere near here, it's really, they're widening these bits of wire here. So that's not brilliant. It's not a problem once the guitar is plugged in, but it's a bit noisy with the guitar not plugged in. I think I might need to ask the customer whether he wants me to try and put a new socket in there. That socket's obviously broken at some point. Okay, so we have a couple of alternatives here. I could put a new jack in, but that requires removing the whole board. It's a fairly big job. So what I thought I would try, this is the ground here. That's okay, we can leave that. This hot signal here runs down, obviously they've just soldered it into where the jack socket went, but that goes on a tray, so all the way around the board, all the way down here, all the way down to here. Quite bad design that actually, on the part of Fender, to bring the very, very low level signal all the way across the board before it gets to anything, any sort of amplification. Not good at all, that. So anyway, what I'm going to try and do, it won't take me more than 5 minutes just to try it, is I'm going to take a piece of screened cable, I'm going to solder ground, I'm going to disconnect this one here, I'm going to solder ground and signal, and bring it all the way down here and tack it onto, tack just the inside of it onto there, to see if that reduces the hum. Worth a go. So there we are, I've soldered it on at that end. Of course this is flapping around now, and normally that would be a problem because this is just open all the way through that track, and although we've soldered this to here, that won't help us. But fortunately, look, there's a little link there which links that track that goes up to the jack into this circuit, so we can actually just cut that, which is what I have done, and connect it onto here. It's a bit crude at the moment, I just want to see if this works. So I would expect this to reduce the hum. If I'd been designing this amp, I would have certainly have done this. I would have had a screen lead coming from here. I mean, the reason this has all got to come wandering down here is, of course, here's the first preamp valve, is they've decided to hang it underneath the bottom of the chassis. Okay, fine, but it now leaves you with a long cable run, open to all kinds of hum and stuff going up to here. So I would have taken a screen lead from there and soldered it, you know, down to here or something like that. But anyway, what do I know? So let's turn it on and see if our hum has reduced. There we go. That's on. There, absolutely perfect, look. So that's fine. I bring my hand there, I can hear a faint hum. So that is actually cured. I suppose we ought to plug a guitar and make sure it still works, but I'll do that now. Okay, there we go. Nice one. That's cured that hum completely. Take it out, as quiet as anything. I'm just going to tidy this up a bit now. So I'm just going to tidy this up now. It's a bit scruffy, and neaten that. And we're done on this amp. I'm quite pleased with that. Okay, I hope you enjoyed that one. Another Fender Blues Junior rescued from landfill, and fairly painless in the end. The customer's very happy, so for a modest amount of money he's got his amp back. He can play it again for another few years. I've got another one of these in the workshop from the same customer, so I might do a video about that one. I expect it'll be a similar story. Anyway, thanks for watching, hope you learned something, and I'll catch you on the next video.